Hey Rick, how are you doing?
Hey, how you doing?
Yeah, pretty good. You can hear me okay?
Yeah, I can hear you.
All right, good. All right, let's see. Let me share my screen. No, not that one. Okay, I think that should be okay. All right. Let's first go ahead and start with any questions that you have. So today is 21st, which means that we are on the last day of module number 4. So any question regarding module number 4321?
Nope.
All right. Yeah, so only a little bit more, maybe like a week or so left. And then you'll be finished with this course. And the next course is about deep learning. We'll use TensorFlow, we'll use Keras. Uh, And I think I mentioned yesterday that it's more about like writing uh, essays related stuff in the next course, but I will try my best to add more exercises or like projects, fun projects for you to take a look at. All right, let's see. So today we are going to do another kind of a classifier, which is known as random forest classification. And random forest can be used for classification as well as regression, but mostly it's used for classification. Now you have already done the decision tree where, based on different conditions, like if a person is employed by Google and the person work as a senior developer, then they make $100,000. Things like that, we did that. So then a random forest classification is also forest, meaning it's a binary, it's a tree, which you can see right here. Well, let me share this article right there. But the difference between random forest classification and the decision tree is in random forest, you create multiple trees. So in this example, they talk about the same stuff where they're talking about like, let's say that you have 6 different trees, meaning 6 different experts or 6 different friends. And you're giving each of your expert or your friend data, and one is saying that, yeah, it's a cat, and the other one is saying, oh, it's a dog. No, it's a cat. The other one is saying cat, and then someone else. So what you do is you take the majority vote that you're getting from your friends, from the experts, whichever one you're asking, and then you can just classify that, well, it's a cat. So that is what the random forest is all about. Basically, you create these things, smaller trees, which are also known as estimators, and they estimate that what that thing is, and based on the majority vote, you just go with that majority vote. All right, and they go into a little bit more detail about, uh, you know, the code and everything. You can definitely check it out. But we are going to look at a little bit of a different code, the code that we are a little bit familiar with, which is, let me see, where is it? The digits code, meaning how can we use random forest classification to perform digits classification, meaning if there are some digits, which is already included in the sklearn dataset, how we can classify them that, oh, this is 0, this is 2, handwritten digits. So most of the things that you're going to see, you're going to be like, well, we have already learned this because most of the steps are same, But in the end, we're just going to use the random forest classifier. All right. So we'll start with importing pandas as PD. And once we import that, if we want to play around with the digits, just like the iris data set, we have already used the digits data set, which is in sklearn.dataset, import load digits. Digits, and load digits is simply a function. So if we call load digits, it will return something. And you can always look at the different properties of digits, which are data, feature names, frame, images, target names. So we have all of these different properties that are available to you. It's always a good idea to draw these digits out. So in order to draw, we will have to do import matplotlib.pyplot as plt. And we can draw these digits in gray color. We don't really need any color from it. And we can also draw only like a couple of them. So let's go ahead and run the loop till like 4 or something. And oops. And we can say plt.mat show digits images of I. So if we do that, you can see that it's going to display the first 4 digits. This is, I think, 0, 1, 2, 3. And by the way, you can access the images property if you don't like to use these things like this bracket. You can always say images also. That is going to produce the same result. See that? It works the same way. But whenever you choose a convention, just choose one and go with that. So I think most of the time we're using this convention. So you can use this, you can use whatever you want. All right. So once we have these digits, we can also create kind of like a data frame out of the actual data. I mean, if you look at these properties, what you have a data property on the digits. But if you print out this data property, like if you say digits data, it's simply a kind of like a one-dimensional array with a lot of different rows. So this is how the digits are being represented. And if you want to show it as a data frame, we can actually do that data frame. It's always a good idea to just look at things in different way. That's most of the stuff that we do in machine learning. We're just looking at things in a different way. And there we go. You can see that from 0 to 63, basically 64 rows. So this is specifying kind of like the 0. Then this one is 1. This one is 2, and so on. And it's 5 rows. Well, that's because I'm printing only 5, but 64 different columns. And we can always check the target also. There's a target property over here somewhere, this one. We can check the target property, what's in the target. So I can say data frame, go ahead and create a new column, digits of target. And then check it out. And it will tell you this whole thing, all of this is basically 0, then 1, then 2, then 3, then 4. So all of these things that are data stored in an array is representing 0. And then all of this stuff is representing 1, and so on. So this is how it's structured, I think, in the data in the data array. Now, what are these things? Like if I say digits of data, what do you think that this actually represents? Like if you just have to guess, like what kind of things it is. Like, or if I say, let's see if I say images, right? This one is, I think, a little bit different. You can see images is kind of like this, but data is consists of this part. All right. So 0, 0, like all of these things, and then the target is 0. So all of the 0 for 0, 0, it's, I mean, I guess it's stored in that particular order from 0 row to 64 columns is just 0. 0, 0 column to 63 column is 0. 0 column to row number 1, 0 column to 63 is 1, and so on. So it's just basically an array, a single dimensional array of numbers that are representing the actual data for that image. And that is what we are storing somewhere, well, in the database, in the table. All right. Let's actually try to, these are the questions. If you want more detail, let's see. Let's see where is, okay. All right, let's see over here. Always a good idea to just ask ChatGPT if you want more information. So let's say load digits. Digits equals to load digits. What is data? All right, so in the context of the digits data set from sklearn dataset module, the attribute data refers to numerical data representing the images of handwritten digits. Here's the detailed breakdown of data contains. It's a NumPy array, and yeah, 64, 8 by 8. It typically has a shape of n samples, n feature, where n samples the total number of images, and features is the number of features representing each image. For the digit data set, each image is 8 by 8 pixel image, resulting in 64 features per image. And then each element of data represented by a grayscale, and then it talks about that. So over here, it talks about that it typically features resulting in, so let's ask it, like, what kind of features I was talking about? All right. Numerical range each number from 0 to 16, meaning each feature represents the grayscale intensity of the pixel, which is 8 by 8 image, where 0 means the pixel is white and 16 means completely black. So when it is actually storing this information, it is actually storing just that. If we go back over here to our code, you can see that since we're displaying it in grayscale, so this one will be like 0, and this one can be like the highest value, whatever they've said over here, 16 or something. 16 main pixel is completely black. So that's what they're storing, the actual dimness or shading, whatever you want to call it, the color value of that thing. All right. Any questions regarding that? So you can see that it goes till 16 over here. All right, let's see what else are they saying. 16, blah, blah, blah. And then they talk about all of this stuff over here. So they kind of like do the same thing what we are trying to do. All right. I don't think we need this. Okay. So we have the data, we have everything that we need. We can start training now. We have, I mean, the images are already there. We're getting it from the load digits. So the next thing we want to do is we want to just start training. And it's always a good idea when we're training to do split for train, test, split. This function, which we have used multiple times, is going to allow you to separate out the testing with the training, which is extremely important. X equals to, we'll drop the column. I think what is df? Well, df is all of this. We can drop the column target. We don't need that. That's the actual thing, like the actual prediction that we want to take. And axis is columns. And y is the target column. So that's simple. Now we can do x train, y x test, y train, y test, train, test, split, x and y. We have done that a million times, x and y. And test size 0.2, which means only 20% will be used for testing. And I think we're done with that. Now we can actually go ahead and train it. So we'll say from sklearn.ensemble, which is like a weird, package, import random forest. You can see that there is a regressor also that you can use, but we're going to use a classifier. Model equals to random forest, classifier. Now, one of the things that you see over here, if you say Shift Tab, is the random forest classifier takes in a lot of different things, but number of estimators, which, I think you can see over here, number of estimators set to 100 by default. So that's already very high, which means number of trees that it's going to create, or number of experts, number of friends, number of experts will be 100 just to begin with, which is a pretty high number. So we should be able to get pretty good, score, pretty good prediction. So we'll say X and Y. Okay, and now we can check out the score with X test and Y test. Wow, look at that. I mean, we are getting like 100%, but it will not always be 100% if I go and run this line again, meaning we get some new data, because this is going to randomize it. Then I run everything again. Nope, still at 100. All right, let's see if we're doing it correctly. Oh, look at that. No, we're doing it correctly, right? No, we're not doing it correctly. This should be not X and Y, right? This should be
X-train.
X train and Y
Yeah.
train. So it already has seen the data. So that is why it's always 100%. So let's do it again now. Need to run all of these again. X. Oh, I think I wrote it again wrong.
Y-train.
X, Y train. Okay, there we go. 96%. Sometimes if it's 96%, you can add n estimators. I think it's already too high, like 100 is already default. I mean, we can try 200, meaning 200 experts. And you're going to listen to majority of the 200 experts or 200 friends, whatever you want to call them. But 200 is pretty high. Let's see if that changes anything. Okay, it went up a little bit from 96 to 97, but that can be based on the training. Maybe the training got different. So you can play around with this value, but 100 is already too high, which is by default. So we don't even have to provide anything. And now we can say predict and text test. That is what we're going to predict. And it can tell you all the different things it finds out. So what is this predict returns? Well, it returns you the prediction, which basically is saying, if I simply print out X test, well, I guess if we look over here, so on, okay, it's kind of hard to read over here. Let's see, how can we, is there a different way that we can look at this? X test is an array. What is number X test? So that's a test. I think I should be looking at Y test, not X test. Yeah, so there we go. So this is the prediction that is returned, all of this, and it is matching against whatever we have in the Y test. Yeah, so it is matching. This means that it returned us the correct results in most cases. Because Y test is the actual prediction. Well, the actual result that we have, and this is the prediction that we're returning from our own functions. All right. All right. There is a way to draw this in a graph. Unfortunately, I never got it to work, but let's go ahead and see. Maybe it will work on your machine. So in order to create that kind of a graph, it's called the confusion matrix. So I'll say FK. Well, let me first go ahead and get some predicted values. So predict is already fired over here. Whatever this returns, we're just going to put it into Y predicted, which is basically going to return an array with all of these different things. Okay, so now this is an array with all of that stuff that we saw earlier on. And if we want to plot this, which never really comes correctly, we will go ahead and say sklearn dot matrix import something called a confusion matrix. So we're going to import confusion matrix on the top. And let's go ahead and run this confusion matrix. We're going to say Y test and also Y predicted. So basically we're trying to, and again, it's not going to work, but what we're trying to do is we're trying to construct something called a confusion matrix in a heat map, which is going to tell us that how many times it was 0 and how many times was it predicted correctly. So let's see, confusion matrix. Now, if we draw this out, it kind of looks like this, which is very hard to see what's going on. I think this is 0 and then 1. It's kind of hard to see. 0, 1, 2, 3, 4, 5, 6. So let's see if we draw this out. So this is 0, this is 1, this is 2, this is 3, this is 4, 5, 6. And in order to view this, we can create a heat map, but that heat map never works for me for some reason. Okay, so looking at this, and I'll try to draw something, but looking at this, we can see that for 0, the first one, this one, 25 times it was predicted 0, and all 25 times was correct. Like, because see, all of this is 0, 0, 0, 0, 0, 0. So it was never predicted anything else. It was always predicted 25. I mean, sorry, it was always predicted 0. But it's not true for every one of those. Let's go ahead and check out this one. It's saying that number 1 was predicted 33 times correctly, but 2 times it was predicted 8. That's what the confusion matrix is telling us. Number 3, for 3, oh, sorry, 1, that was 1. Number 2, 34 times 2 was predicted 2. So that's good. If you look at this one, for number 3, 38 times 3 was predicted correctly, but 3 times it was predicted 9. I guess 3 and 9 are a little bit similar, maybe, I don't know. But this is kind of like a hard to follow. And for that, they create like, no. Okay, for that, they use something called heat map, but unfortunately that never works for me, but I'll try it out. So this is in a library called Seaborn. So I'm just going to go ahead and import that library. Now, if you don't have that library, then you can always install it. You will have to say conda. You will have to stop your Jupyter notebook, conda install Seaborn, and that's it. So if you don't have this, you can run this conda install Seaborn, making sure that you're connected to the right environment. I already have
I
that
think
installed.
we installed it when you, I think one of the assignments or something was dependent on, I think that's when we
okay.
installed it.
Okay, good. And then we can see the figure size, fig size 10,7, 10 rows, 7 columns. You can change this. Maybe it will work on your machine, but for me, it doesn't work. So now we can create that heat map. Basically, we're trying to create the same thing, like this thing, but with automatic numbers and nice layout. It does create it, but it doesn't add all the numbers. So if I say annotation true, so it did create it. You can see it created it, but it's missing all the other numbers. It's missing basically everything. Like there has to be some numbers over here, and 33 has to be over here. So I'm not sure what happened, but it just doesn't show me the numbers. It just creates it like that. Even though we have, I wonder if we have to, yeah, we are using CM, which is already a confusion matrix. So it should be plotting these things. But let's see, maybe ChatGPT can help us out. How to plot heat map for this. You can use Seaborn library. That's what we're doing. Okay, it's writing way more code. Yeah, I don't. Oops, what's happened over here? I think that's basically what I did. I don't think it's doing anything. Digits dot target name. We can definitely try it out, but I think instead of this, we already have the digits. It's gonna just color it to blue. Let's see if it does something. SNS is not defined, so this should be simply SN. Yeah, see, it just changes the color and added some labels to it, but it misses all of these. I mean, this should be 33. And right at the bottom somewhere, it should be like 2. It actually, I can see a little bit of a shading going on over here. You can see a little bit of shade. It creates these shades, kind of hard to see, but these are
Yeah,
not
the
filled
colors
out.
look accurate. It's just not putting
Yeah.
the numbers.
And yeah, you can see the 3 should be there. And then, well, there are more numbers. 1, 2, 1, 2, and 1, 2 over here. So there, this look accurate and that looks accurate. Yeah. but I'm not sure why it's not putting the numbers. Target digit dot target name x tick and then y. These are different things. Yeah, I'm not sure. An FMT. Let's see what these things. Okay, there's something else. Mask is none. Yeah, for some reason it doesn't display the stuff. Or else it would have been nice to see basically what these things kind of look like in nicer way with something called confusion matrix. All right. But we learned about how to use random forest classifier. There is another, let me actually see if I have the code for it. I think it's called, I know that we use, where's the function? Score to get the score of the thing. But there is like a cross. Let me see if maybe this can help us out. Use cross validation to check the score. Cross val score, CLF, that's fine, XY, TV, okay. I think we can import that. So cross validation score or cross val score allows you to quickly do the score. What does that mean? Let me actually see over here. Score, which is we already predicted the score somewhere, right? I mean, it was like 0.97, beating 97%. But this one is a little bit more advanced technique. So we have cross val score from model selection. And in cross val score, you can actually pass in the algorithm, which is, what is that called? Random forest classifier as an instance. We can pass in X, we can pass in Y, and let's see what else we can pass. CV is none. Cross validation default the cross validation splitting at strategy. Okay, so CV, whatever we can put it, let's say 5. Okay, so this is what the score is finding out. 1, 2, 3, 4, 5, and now you can kind of like do the average of this. Now you might say, well, why would I actually use this? Why can't I just use the score, which we have used somewhere? Where is it? This one, model.score, right? Why can't I just use that? You can use that, but the good thing about this is I can just copy paste it. And if you know any other classifier, we can use it over here. Let's say, what is it? Logistic regression, right? Do we have to import something for that? Probably we have to import. So we can just import from sklearn dot, let's see, where are we? Let's see, let me double check it. Import logistic regression. I'm just trying to see where it belongs to. I think it belongs to the model, the linear model. Okay. So from sklearn dot linear model, import logistic regression. And then we can create an instance of logistic regression. Oops. Oh, maybe it doesn't like it. Well, it did something. So that's the beauty of this. I think it's just saying maximum iteration are achieved. But that's the good thing about the cross-val score. You can just pass in different regression algorithms over here, and it will tell you the score. So you can see the score 92%, 86, 94, 93, 89. And you can kind of like compare it with this. They are both good, but I think random forest classifier is much better. They're more things percentage in 90s. Do you remember any other classifier that we use? I think K, what is it called? The
Yeah, K nearest neighbor.
K nearest neighbor, or let's see, import K nearest neighbor. Okay, I'm just trying to see where does it live? All right, K nearest neighbor. I don't remember that it lives in something called neighbors. Is it? Okay. And okay. Then we can go ahead and do the same thing. I'll go over here. I'll copy this line. Probably just have to create an instance of that. Nope, this one didn't work out. No, so something went wrong over here. Probably K nearest neighbor requires something different, maybe. It is possible. Oh, maybe, no, that is fine. I did import it like correctly. About, let's see. Yeah. So whatever you, like the classifier you want, you can always put it in the Crosswell score, and it will give you the score. So that's a pretty easy way to find out the score, that what exactly the score for different models or different algorithms, and then from there you can do whatever you want. Like, okay, I want to go with logistic regression, or I want to go with random forest. This will be up to you once you apply, once you know the score. All right. Any other questions?
Nope, makes sense.
All right. Okay, so the question now is, can you use this the random forest to perform the iris classification, which we learned yesterday? How can you use the techniques that you have learned to classify the iris between setosa, versicolor, and the other one, the three different classifications? So how can you do that? All right, and let me see if I can get this. This is random forest classifier, and I'll try to see if I can give you this file so you can play around with it. This is this one probably. There we go. All right, so I'm going to open up the breakout room and try to see if you can classify the iris between setosa, versicolor, and virginica. Yeah, using random forest classifier. There we go.
Hey.
Yep.
Looks like the score is perfect. I ran it twice. Hopefully I did it. Yeah, it's
for
1.0.
tulips. You sure you're passing the correct X test, Y test when you're predicting?
I did the model.fit with X train, Y train.
Okay.
And then I did the model.score with X test, Y test.
Okay.
I'll share my screen just to make sure I didn't do something wrong.
Okay. It's kind of rare to get 100%. Iris data. Okay. Iris target. Okay. Let's scroll down. And then we have all of that stuff. Wait, what is X over here? Maybe I missed that. The capital or uppercase X.
So first I made the data frame
Okay, so I think it's, let me see
here.
over here. I think you're doing the X over here, right?
Yes, I just said X equals
Okay.
data frame.
All right. So I'm wondering, is it by reference? If you print out X over here, just print out X dot head. How do I delete this? Yeah, X dot head. I just want to see what's in the X dot head over here. Okay, you can see that there's a target column in there in the X right here. That shouldn't be there.
Oh, it's because of this right here. So if we I assign, well, why is it
So
doing that though?
I think it might be because this is by reference. So what you're doing, yeah.
Oh, okay.
So probably you should do df dot drop or something online number, whatever that is. Yeah. So you should do
Okay.
df dot drop, and then we can see that how it changes. Because now it already knows about the target.
Okay. Yeah.
That's why. So yeah, but you will still have to drop. I mean, oh, it doesn't have that column yet. Okay. So yeah, so you can do it in the next.
I didn't know it worked like that. Okay.
Okay, so yeah, so do
I'll
X
do it.
and then df dot drop. Yeah, there we go.
And
And then you're
then
gonna drop the target column, access columns. Just
I
a
forgot, do we
string.
do df in here or
No, just a string. You just pass in the string, the name of the column that you want to drop.
okay.
So it should be just in a string, which is target, comma, and then access equals to columns.
Okay.
Okay. And now if you run kind of like the whole thing, we can see what that score will be.
I guess I'll just rerun all the
yeah, there should be a button over here to run, and then in the run there's like run all cells. Yeah.
Okay,
Okay, there
that
we go.
makes
Now
more
it's much better.
sense. Yeah, that makes more sense.
There we go, 96%, which is pretty good. Okay. Random forest classifier. Okay. Okay, yeah, there we go. 96%, pretty good. Yeah. All right, so that is pretty much it. And I think tomorrow we're going to look at some other algorithms. Let me do this one. But remember the website kaggle.com, I think, right? You can always go over there and try to play around because they have a lot of samples, like a Titanic sample. And sometimes they have, I think, the real data also. So you can definitely play around with that. And you can also, well, depending on the kind of data, you can create the website using what did we use? Flask. You can create a website using Flask, so those can be really cool. Like an actual website where you're selecting, okay, cholesterol level, height, weight, and then it will tell you heart disease, yes or no, kind of like those things. So those are practical things. Yeah. And you can also create like Flask website, which is just a API, meaning it's just going to return you JSON. And since you are already comfortable with web development, so Flask can only return you JSON result, and then you can consume it in your favorite JavaScript language or whatever you want. The interface you can build at anything, or even an iPhone
Right.
app. Yeah, I mean, iPhone, Android, whatever app that you want to build, you can always do that. So that's kind of cool. Yeah. All right. Any other questions before we wrap up?
Nope, that was pretty clear.
All right, then I will see you tomorrow.